Hi guys, welcome to lesson 8.1, adding and subtracting polynomials.
Hi friends, it's me. I'm here.
Yes, she's back. Ms. Urzo makes her triumphant return. All right, so our objective for today is that I can classify, add, and subtract polynomials. Now, vocabulary, we haven't had much of this lately, but here's a whole bunch of it. A monomial. Mono means one. And rail means rail. Monorail.
Monorail.
All right. A real number, variable, or product of a real number and one or more variables with whole number exponents. That is a monomial. Mono means one. All right. The degree of a monomial is the sum of the exponents of its variables. The degree of a non-zero constant is 0, and 0 has no degree. Okay? A polynomial, poly means many, polynomial is a monomial or a sum of monomials. So we're going to be adding a bunch of them together. Think equations that we've seen. Those are polynomials. The standard form of a polynomial, the degree of its monomial terms decrease from left to right. So your highest exponent is to the left, your lowest exponent is to the right. So Mrs. Urzo is putting some numbers in proper order. We got x to the fourth, x to the third, x to the first.
X is the same as x to the first?
Yep. But we could put a constant in there, like a 3 at the end, because that has a degree of 0. And the degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. All right. And our essential understanding, you can use monomials to form larger expressions called polynomials, and we can add and subtract those polynomials.
You guys missed me, didn't you?
All right.
So a degree of a monomial.
So problem number 1, finding the degree of a monomial. And we remember we need to add up the exponents on our variable terms. So x and y each have an exponent of 1. Add them together. This is a second degree monomial.
So all of these are monomials. So you're adding.
All right, so we have -7. That has a degree of 0. We have 4 on the y and 1 on the z, so that is a 5th degree monomial.
Yes, you must write this out. You are in algebra students. You can write 2 words.
Yep. X squared, y to the 5th, 2 plus 5 is 7. So it is a 7th degree monomial. Now I want you guys to try D, E, and F, and then we are going to go over them. All right, letter D, we've got x to the 4th, y squared, z squared. So that's going to be an 8th degree monomial. Letter E, we've got z to the 3rd, y to the 5th. That is, again, an 8th degree, not 8th grade. You guys are in 8th grade, or maybe 7th or 6th. All right, and F is m to the 4th, n to the 1st. 4 plus 1 is 5. That is 5th degree. We don't have any 5th graders around here. All right. Now, problem 2, adding and subtracting monomials. What is key here is you need to make sure that the variable factors are exactly the same in order for us to add them. This is going back to that old skill that we've practiced called combining like terms. So you were adding and subtracting monomials and you didn't even know it. All right, so in letter A, we have 2 x to the 4th terms. -6 plus 11 is going to be 5x to the 4th. Letter B, x squared y to the 4th, looks the same in both ones, so we can subtract that. 2 minus 7 is -5x squared y to the 4th. Letter C, we've got c cubed d squared. 2 plus 5 is 7. 7c cubed d squared. All right, I'd like you guys to try letters D, E, and F. And again, we will go over them. So, letter D, 2x squared plus 7x squared. We have 9x squareds. Letter E, we're going to first look at those two. We've got x squared terms. 3x squared minus 4x squared is negative x squared. And then we have that plus 6x squared y. That can't be combined because it has a y term and the other ones don't. Letter F, we've got 6y squared minus y squared, and that's going to be 5y squared. And then we've got 3x cubed, so we're adding 3x cubed. There's no other x cubeds. And there's no other 5x squareds. All right, so it's just 5y squared plus 3x cubed plus 5x squared. All right. Next section, classifying polynomials. Now, in order to classify them, we're going to label them by their degrees. We're going to give them a name based on that degree. We're going to label them based on their number of terms. And we're going to give them a name based on their number of terms. So if we remember back to our definition, a constant that is non-zero has a degree of 0. So it's going to be 0 for our degree. And what we call that is a constant. It is just 6. It is constantly there. And there is only one term that's being added there, and so that is a monomial.
You must write the word.
Yes. Full word, correct spelling, spelling counts. All right. Our second polynomial is 5x plus 9. So we said the degree was the highest exponent, and that is going to be the first degree. And we name those linear. It has 1, 2 terms, so that is a binomial. Bi means 2.
This takes me back to science class.
All right, next up, we've got 4x squared plus 7x plus 3. So our highest exponent there is 2, so that is a second degree polynomial.
Why don't you add them?
Because they are not single terms. In a polynomial, our degree is the variable with the greatest exponent. So this is made up of 3 separate monomials that are added together. All right, so we have 3 terms, but we skipped our name. We call these quadratics. And that is what this chapter and the next chapter are all about, and they are a lot of fun. All right, 3 terms. Well, 3 wheels on a vehicle is a tricycle, so we're calling these trinomials. Tri means 3. Triceratops, 3 horns. Okay, moving on. X cubed is going to be third degree, and we call these cubics. And that is just 1 term, so it is a monomial. All right, next up, 8x to the 4th minus 3x squared plus 5. So our highest degree is 4, so it's the 4th degree. And we don't have a fancy name for this, so from 4 on up, we just say whatever degree, so 4th degree. It has 3 terms, and we call those trinomials. Okay. All right, so now going down to the questions below, we have write each expression in standard form. What is the name of the polynomial based on its degree and number of terms? So remember, standard form, we are decreasing our exponents from highest to lowest. So letter A, we're going to start with our highest exponent, which is a positive 8x squared. Remember, the sign in front of the number is connected to it. And then we get the 2x, and then we get minus 3. So that is going to be a quadratic trinomial. Its highest degree is 2. and it has 3 terms, quadratic trinomial. All right, letter B, 6x plus 2x squared. So our x squared term is going to come first, plus 6x. So this is going to be a quadratic, because our highest exponent is 2. And it's a binomial, because there are 2 terms. Okay. I want you guys to try letters E or C and D, and then we'll go over them. So letter C, we're going to start with our highest exponent, which is that x to the third. So we have negative 4x cubed. Don't forget the negative sign. Minus 3x squared plus x squared. Combine those like terms, and we've got minus 2x squareds. And then plus 2. So this is going to be a cubic trinomial. All right, letter D, I was mean. So we're going to start off, our highest exponent is to the 5th power, so we have 3x to the 5th. And then I see we have an x to the 4th power, so plus x to the 4th. Now we're going down to the 3rd power, so we have negative 2x cubed plus 4x cubed, so that'll be plus 2x cubed. And then we have an x squared, so minus x squared. And we have an x, and we have a minus 4. So our highest exponent is 5, so this is a 5th degree. And this is where I wasn't very nice to you. It is just a 5th degree polynomial. We don't have a fancy name for it.
That was fun, Mr. Bowman.
Yeah.
I like this chapter.
Yep, it's a lot of fun, isn't it? Just wait until we start doing factoring and distributions, and we teach you a new acronym that comes with a terrible pun, and it'll be great. You guys are going to love it. My class is already afraid of the pun. All right, problem 4, adding polynomials, otherwise known as combining like terms. So there's 2 ways you're going to see problems set up. One set up vertically with like terms above one another, and the other one is going to be set up horizontally as 2 polynomials that are being added together in parentheses. So you can approach it either way. The vertical method, we're just going to look up and down. We're going to add our terms up and down. So negative 7x squared plus 21x squared is 14x squared. Negative 180 minus 140 is negative 320x. And 5800 plus 1900 is 7700. And that's all we have to do. So this is really just like when we learned elimination when we were solving systems of equations. It's a very similar concept. All right, so what we can do when they're horizontal is I'm going to look and see what in my next term or in my next polynomial is the same as 4x cubed, and I don't see anything else. So I just rewrite 4x cubed, so that one's done. So then we've got an x squared term in our second polynomial, so plus 7x squared.
Nothing to combine with.
Nothing to combine with. Next we're going to go down to our x's, so we have a negative 2x plus a 3x, which is just going to be x. And then we have a positive 4 plus 18, which is 22. Okay. So whichever way you choose to do it is up to you. If you want to take one like letter B and rewrite it like it's letter A, that's fine. That's your choice. We're not gonna dictate one method or another on you as long as you are combining like terms appropriately. All right, letter C. These two, C and D, I want you to try on your own. So letter C, we have 42x squared plus 2x squared. That's 44x squareds. Next up, we have just our x's. So 5x plus 4x is 9x. And negative 8 plus 7 is negative 1. Okay. Letter D, we just add vertically. 8x squared plus 2x is 10x squared.
You didn't give him a mean one.
I know. 10x minus 14x is negative 4x. And negative 26 plus 18 is negative 8. I know.
You didn't give him any mean ones.
I know. I guess you'll just have to give him the mean ones for the in-class assignment.
Oh, sounds like a plan.
Yeah. Okay, problem number 5. We have letter A is 3x squared minus 4x plus 8 minus the quantity 4x squared plus 3x plus 2. So what Mrs. Zirzo did is she distributed that negative sign to all 3 terms within the parentheses, because that's what the distributive property tells us. So 3x squared minus 4x squared is negative x squared. Negative 4x minus 3x is negative x. And 8 plus 2 is 10. Sorry, it was negative 4x plus 3x, otherwise known as minus a negative. That's what I was initially thinking. You're good. All right. So letter B, again, you're going to have to deal with distribution. So this would be a good time.
This is a bad one. I like it.
Yeah. So you need to distribute that negative sign to each of those terms, and then look and see what we can combine. So we have a negative 4m cubed. There's no other m cubeds in the polynomial. And now we've got minus 4m squared. So this is kind of bad.
Mm-hmm.
So now we've got negative m minus m, so that's negative 2m. And we have a 9 plus a 12, which is 21. Okay, I want you guys to try letters C and D on your own, and we'll go over them. So first step, distribute the negative sign in your second parentheses. You have negative 6x cubed minus 5x squared plus 4. So now we've got 2x cubed minus 6x cubed, so that's negative 4x cubed. 4x squared minus 5x squared is negative x squared. Minus 3x, there's no x term in our second polynomial. And then plus 4. Okay. Letter D, 8x squared plus 10x minus 26. Make sure you distribute your negative sign, and it's a good idea to do what Ms. Zirzo has done, is scratch out your equation after you've distributed it. 8x squared minus 2x squared is 6x squared. 10x plus 14x is 24x. And negative 26 minus 18 is negative 44. All right, so that is the end of our notes for today. Make sure that you go through and fill out your level of understanding and your summary. Write down any questions you may have. And we have Tic Tacs. We will see you in class tomorrow.